Welcome back students. So in this video we will be doing the remaining part of refraction and then problems on what? Refraction. So in refraction already we have learned the refraction due to what? Plane surfaces like a glass slab or water surface something. Okay. In this topic we will learning the refraction due to what? Curved surface like a concave shape or convex type of surface will be there, which later we will call them as a lenses. Okay. So refraction through curved surfaces we will learning. Okay. Let's write heading. Refraction through what? You call it curved or spherical surfaces. Okay, like reflection also we did this. First we have learned reflection due to a plane mirror, right? Na? Reflection. Then we learned reflection due to curved mirror like concave mirror and convex mirror. Exactly same thing we also be learning here. First already we learned reflection due to plane surfaces. Now we are learning reflection through what? Curved or spherical surface, means convex surface or concave surface, right? Na? Okay. So it's very easy here, just one case only we have to do. So look here what you do. Suppose we take some curved surface, okay, any type of surface, maybe concave or convex like this. Okay, this type of surface I am taking. So this is called convex surface, and here there will be always two medium. One medium is what? Air generally, and second medium will what? The object which is surface is made up of that material. Okay, so we call two names. One we call refractive index mu1, one we call mu2. So what is mu1? These things you have to understand carefully. Okay, it's very important. Mu1 is the refractive index of the medium in which your object is placed or your incident rays are coming. What is mu1? Refractive index of medium in which object is placed, or you can say that incident rays are coming, right now, or incident rays lies you can say, right now, is a medium in which your object is placed or the incident rays are coming through that medium, right now. So that we will call refractive index as mu1, correct? Yes. Okay, then what is mu2? Is a refractive index of medium in which either you can say your image is formed, right now, which image is formed, or properly you say that your refracted ray, what you can say, refracted rays lies, right now, correct now? Mu1 is the refractive index in which what? Your incident rays are there, and mu2 is the refractive index of the medium in which what? Your refracted rays, or you say your image is formed, right? Okay, look here. So object can be placed inside this, outside this. This surface can be convex shape, concave shape, doesn't matter. Okay, yes. So they define small points. Okay, so look here. This is what your pole again, right now. Okay, I draw a line like this way. Okay, this is again your pole only. That is called what? Your C or R, center of the curvature or radius of curvature, means radius of this spherical surface, right? Okay, generally we'll write R here. So this is what your R, correct? Then what you will do, you will put your object somewhere, either you put what in this medium or that medium. Suppose I am putting object here, this is your object, then this medium will be called refractive index of what? mu1, and this will be called what? mu2, right? Okay, light will come from this object, come to the surface, and it will get refracted. Suppose I draw a perpendicular line which always meets with what? Your center of curvature, you know, right? So then this is called your angle of incident, correct? And suppose image is formed, refracted ray comes here and make an image here, that's your image formed, right now. So this is called angle of refraction R, correct? Yes. Now with respect to pole, that distance is called object distance u, and that is called what? Your image distance what? V, and radius of curvature. Three things we have, like normal mirror formula we write like in terms of focal length, object distance, and image distance, right? Here we will write the formula in terms of object distance, image distance, and the radius of the curvature, right? Okay. So now what is the relation? A small derivation we are not doing here, but not much useful for us. So directly I am writing the answer. What answer comes when you do like this one, okay? But focus here once more. mu1 is the refractive index of the medium in which your incident rays lies, okay, and mu2 is the refractive index in which your reflected rays, or you say your image is formed, right? So when write this relation, how it looks, look here, it look like this way: mu2 by v minus mu1 by what, u, is equal to what, mu2 minus mu1 by what, r. This one single relation will answer all questions based on what, your curved mirror, right? Refraction through what, curved surfaces, like that one. So nothing to explain here. V is called your image distance from pole, you know this. U is called your object distance from the pole, and r is called what, radius of curvature, right? So here you have to give attention to what, sine convention always, okay? Generally, like in this situation, object is placed here, so light going that direction. So suppose you measure the distances from this point P, then it's that object distance will be what, negative, right? Image distance will be positive, radius of curvature will also what, positive, right? Same sine convention rule you have to use here. Okay, let's say if you want to see, I draw some picture, you understand how it looks. Suppose in this case you understood, in this case your R is like what, positive, because light coming like that way, right? Light coming like that way. So U, object distance you measure, that will be what, negative, right? You going against the light from this point. Image distance you going this direction, that will be what, positive, and radius of curvature will be also what, positive, right? Okay, so we'll do numerical on this, you'll understand. Okay, so now what I'm doing, we will do questions on what, refraction, all topics that we have learned, like those normal shift and apparent depth, all these things, okay, TIR. Okay, first I do questions on this so you understand better. So if you see your worksheet, if you pick your worksheet, directly come to the last questions which are based on this topic, okay, refraction through curved surfaces. So we understand these first. So actually first I am doing question number 13 and 14. Two questions I took example based on what this. So look at the problem number what, 13. Then I will do the other problem, okay. 13th problem, let's see. They said an air bubble in a glass of refractive index mu is what, 1.5, situated at a distance of what, 3 cm from a spherical surface of diameter 10 cm as shown in figure. At what distance from the surface will the bubble appear if the surface is convex and what, concave? So two pictures are also given to you. We have to find at what distance from the surface the bubble will appear, means they are asking like apparent depth, that's also called what, your image distance, right now. So they are asking what is image distance simply, because whatever image distance that we will see actually really, okay. So that's called apparent depth also. So look at first case. First they have given a convex surface. This is your convex surface, right now. Yes, this is a convex surface, and object is placed inside this medium, like object is placed what, here, this is your object O. Okay, so it's making some image like this way, and here is making image, and that's your center of curvature. Okay, look at what is given to us. You can see all picture. Mu of this medium is given. Okay, so look here, the medium in which your object is placed, correct now? Object is placed, that's called, what you call that? That you call as what, mu1, right now. That is given here, this glass given 1.5, because your bubble is what, in the glass here, okay. So that will call what, mu1, okay. And outside your air is given as what, we will call mu2. Refracted light is traveling this medium. Actually I should I should do a small correction here. You should not say like this way. What is mu1? Refractive index of medium in which object is placed. You don't write like in which incidence rays are, right now, rays lies, right now. What is mu1 is the medium in which incident rays are there, okay. And refractive, don't say like object and image, because sometimes image can be formed in the same medium, like here also what image formed in this same medium itself. So it's confusing, so better say mu is the refractive index in what incident rays are there. Incident rays are traveling here, refracted rays are outside, you see, right, other medium, okay. So in which you said that refracted rays lies, okay. This will be more better, so no confusion, okay. So object is here, incident rays are in this medium, so that will be called what, mu as what, 1.mu1, that will call mu1, and this is what refracted ray, this will call mu2, that's given as what, 1. Okay, this is given. Then what they gave, this object distance and radius of curvature given, are given 5 centimeter, object distance given how much, 3 centimeter, and they are asking what is the distance of the image. Means we have to find image distance, or when you watching from outside at what depth it appears. Okay, okay, let's write normal formula. What is normal formula is here, mu2 by v minus mu1 upon u is equal to what, mu2 minus mu1 by what, r. Correct. Now let's put the sign conventions. Okay, mu2 means what. Okay, here let me put here sign convention itself first. Here v, u, v and r, this sign convention. Okay, look, okay, let's put the value also. mu2 is the medium in which what your reflected rays traveling, that already I wrote as what, this one, so 1. Image distance we want to find, they are asking that at what depth that bubble will appear, that's called your image distance simply. Right now image distance you want to find, so no sign convention, v alone, minus u1 means what, 1.5. Object distance is what here, negative or positive. Look here, object here, light going in that direction. Right now this is direction of light. From here we measure object distance, we going this direction, so u will be what, negative, so it's minus, and u already got given to us what, 3 centimeter, this is 3 centimeter. We have put sign convention here, minus, keep in mind, is equal to what, mu2 minus mu1, mu2 minus mu1, 1 minus, okay, let's write 1 minus 1.5 divided by, what is the radius of curvature, sign convention. So radius of curvature also we measuring in this direction against the light is coming like that way, so this should be also what, negative and minus 5. Okay, so this is 1 by v, minus become plus, 1.5 you want, you can write as what, 3 by 2, correct. This is actually 1.5 by 3, so you can write it half also, your choice. Okay, like that way. Okay, here we have what, 1 minus 1.5 means minus 0.5 and minus get cancelled, 0.55 means you can write this as what, 1 by 10 also, correct. Okay, so this is your final answer, that 1 by v should be equal to what, 1 by 10 minus 1 by 2, 10 you took LCM, 10 goes what, 1 time, 2 goes what, 5 time, so you are getting minus 4 here. So v will be equal to actually minus 10 by 4 or minus 2.5 centimeter. So you're getting your image distance at what distance, 2.5 centimeter, and you're getting answer as negative, means image formed in what, in this side only, right now. This is your pole, so image formed somewhere here like that, right, negative distance coming, so it's formed inside this your lens or some curvature, some surface given there only, right. Okay, now look here, another case of this also given. What is given here, they said that if same object is what, second case of this we are doing, question number 13, second case B. If this surface is what, concave surface, right, one is given convex surface, this surface was convex, one is given concave surface, then what will happen, look here. So what will change, let me draw picture also given, so let's draw it. This type of surface you have, other things remain same. Look here, this is object placed here, this is your incident ray, refracted given somewhere here, and we don't know where the image forms, suppose formed here itself, that's your center of curvature. Okay, so again all values are given, object distance given 3 centimeter only, radius of curvature given 5 centimeter, right, everything remains same only, and mu also, this medium that will call mu, this is a medium where your incident rays are there, so that will call mu1, which is given 1.5, this is a reflected ray, that's called what, 1. Okay, this is given. So actually what have changed here, just one thing has changed. Okay, surface type, this was convex, this was concave. Okay, I wrote one thing wrong actually, can you see here what is wrong? Yes, this is wrong, I wrote center of curvature here, center of curvature will be outside, right, here, not this, because curvature circle like that way, right now, so center of curvature will be somewhere here, this is center of curvature, that distance is given what, 5 centimeter, that's all. Okay, yes, here curvature was like this one, so center of curvature is on this side somewhere here, right. Okay, so same formula, let's write it again, this formula only, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by what, r. Done. Let's put the values with sign convention. What is mu2? mu2 remains same, is 1 only. Image distance you want to calculate, yes. Okay, mu1 means what? 1.5, and object distance, correct. Object is placed here. Object is placed here, light going in this direction, right? So measuring distance from pole, that we going against the light, so u is what? Negative. And how much given? 3 centimeters, so minus 3 centimeter here. Mu2 means what again? 1 minus 1.5 divided by r. What is r here? Value is 5 centimeter and is what? Positive. Why positive? Because radius of curvature on this side now, okay? Direction of light is going from here to here we going, so this is what? Positive value. R is what? Positive means what? Your plus 5 here. Last time it was what? Minus 5. This was only change in this both situation, right? So 1 by v is equal to what? Same thing only. 1 by 2 is equal to, this become simply minus 1 by what? 10. Here just positive, here coming what? Negative. Okay, so 1 by v will be equal to what? Simply minus 1 by 10 minus 1 by 2. 10 into LCM, 10 goes 1 time, 2 goes 5 times, so this become minus 6. So v is this your answer? Minus 10 by what? 6 centimeter. Here again answer is coming what? Negative only, means again image is from here inside this only, but you see 10 by 6 means at smaller distance as compared to what? That, right? There's a difference. Okay, so hope you understanding. Very important how to write mu1 value, how to write mu2 value. Mu1 in which incident rays are there, mu2 is a medium in which what? Your reflected rays are there. Okay, be careful. Okay, there is one more question here, that's called question number 14, based on same concept. Let's do it. So this formula, right, very important, that this formula is applicable to all type of surface, all types of what? Surface. Means you can apply to a plane surface also. Yes, you can apply. You can apply convex surface, concave surface, any type of surface. This formula is applicable. This thing you only have to understand. Okay, you can apply to any surface. So question number 14 we were talking. They said that calculate the refractive index for the given situation. So some sphere is given to you, spherical like surface given. Rays are coming parallel. And you understand when rays comes parallel means they come from what? Infinity, right now. Then they said they are meeting at some point here. Okay, like this. Okay, so this is given air and this is given some glass of refractive index mu. This is given right now. Okay, so they are asking that what is the refractive index of the given situation. Look here. So in this situation we have to find what? Refractive index of this, some glass surface or something is given. So rays are coming parallel, means from where the rays come parallel, obviously they come from infinity. So u will be what? Your infinity first thing, right now. Parallel rays are coming, means the object is placed at what? Infinity. Okay, then image formed at this point. Yes, suppose this is your pole, then image from this point means that distance, image distance also we know. What is that? V simply equal to 2r. R is the radius of curvature of this surface, right? So what is image distance from pole? This is surface, right? So what is image distance? Simply what? 2r. The rays are meeting at this, the other diametrically other end, right now. Okay, so image distance also what? 2r. Okay, r is the radius of curvature, and object distance we have calculated about infinity already because rays are coming parallel. Now look, let's write a formula, same formula. You say that mu2 upon v minus mu upon u is equal to what? Mu2 minus mu1 upon what? Radius of curvature. Okay, let's define again what is mu1 and mu2. Mu1 is the medium in which incident rays are there. So this incident rays and air, that's what is mu1, which is equal to what? 1. Correct na? The refractive index of air is what? 1. Mu2 in which reflected rays. So reflected rays are here, that's called your mu2. This mu2 we have to find. So mu2 we calling what? Mu symbol actually. Okay. Okay. Mu2 we calling what? Simply mu symbol. What's image distance? Image distance is what? 2r. Positive or negative? Light going this direction. We measuring from pole. We going this direction only. So your 2r is what? Positive plus 2r. That's your image distance. Okay, mu1 means your refractive index of air, which is what? 1. Object distance is what? Infinity. Is minus, yes, we measuring direct your distance of object from here, like going against the light, and is what? Infinity. So minus infinity, okay, is equal to what? Mu2 minus mu1 means mu minus what? 1. Clear? By what? Radius of curvature. Radius of curvature also what? Positive, because we are going in this direction, right? That's what your radius of curvature. Okay, so look here, mu upon 2r. This term becomes 0, 1 by infinity, simply equal to what? Mu minus 1 by r. R you can cancel, right? So if you simplify this, what you will get? You will get mu is equal to 2 times of mu minus 2. So 2 is equal to what? Mu. That's your answer. Mu is equal to what? 2. So this is the refractive index of that medium. Hope you are understanding this. Okay. So these were questions I did based on what? Refraction through what? Curved surfaces. Then in this sheet I have other questions also. So let's do questions from beginning. So look in your sheet. If you see your sheet, then up to question number 6 already we have done, which were based on reflection in the previous lecture. So question number 7 onward we have to do, okay, from 7th onward. Okay, so okay, let me do one question, then I will clean this board. Question number 7 we are talking, recent sheet, question number 7. Okay, so question number 7 says that it's based on what? Your normal shift. They said a mark at the bottom of a liquid appears to rise by what? 0.2 meter. The depth of the liquid is 2 meter. Find the refractive index of the liquid. You have some pot, okay, liquid is filled here, real depth is given to you. What is the real depth of liquid fill? Is what? 2 meter. Some object is placed here, is raised up here, means what is given to you? Normal shift is given to you. Is looking toward raised by what? 0.2 meter, means normal shift is given 0.2 meter. They are asking that real depth given, they are asking what is the refractive index. So we know normal shift formula is what? Normal shift is what? Your h real what? But real depth minus 1 by mu. This is the formula, right? So normal shift is given 0.2. H real given what? 2 meter. Directly I am sending down here. So by 2 is equal to 1 by 1, right? Okay. So this you can cancel, you can write as 1 by 20 is equal to 1 minus 1 by mu. Okay. So 1 by mu will be equal to what? This I am sending on this side. So 1 minus 1 by 20, that becomes what? 19 by 20, or mu is opposite of this what? 20 by what? 19. That's a refractive index of that liquid, right? Okay. Okay. Question number 8 we are doing now. So in question number 8 they are saying the fish is at depth of what? 30 centimeter below the surface of water. If the refractive index of water is given 4 by 3, find out the distance between the fish and its image. Distance between object and image they are asking, which is called normal shift, right? Okay. So some fish tank is given. This is fish tank and is filled with water. Suppose this is your water. Water height is given to us. The side is 30 centimeter. And your fish is what at this point. So you are watching from top. So at what depth this will look? It will not look really here, because normal shift will be produced. So it will look somewhere what? Here. So this is called your object, then this is called your image, and the distance between object and image, this is called your normal shift. Correct? So normal shift you can write two ways. One normal shift you can write, if you know h real and h apparent, you can write like this way. Or if you know refractive index, like in this case refractive index is given, mu is given as what? 4 by what? 3. So normal shift also equal to what? H real 1 minus 1 by mu. Here object is placed in denser medium and you are watching from what? Rarer medium. So this is a normal shift produced, right? Okay, let's put all the values are given. Normal shift value obviously 30, 1 minus 1 by mu. So it's become what? 3 by 4. So it's become 30 into what? 1 by 4, 7.5 centimeter. This is the gap or distance between what? Object and image. Correct? When normal shift is happening, or you can call also what? Normal shift. Suppose there's apparent depth. At what depth it looks, means they are saying image distance. So what? You know this formula you can write. Real distance we know 30, normal shift we have calculated 7.5. So you can find apparent depth, means that much depth you can find. Okay. Okay. So let's move on. Question number 9. Question number 9. It says that an air bubble inside a cubical block of glass of side 4.5 centimeter is appears at 2 centimeter when is viewed from what? One face, and let's look at what? 1 centimeter when is viewed from what? Opposite face. They are asking what's the real distance of this bubble from the first face. Look here. So a cubical block is given to us, transparent block, and they said the side of this is what 4.5 centimeter, right now. They said there is a bubble here. Suppose real is what here. Since when we look from the top, apparent distance given, look at what 2 centimeter from the top. Say when you look from other face, say from bottom, it looks at what apparent distance 1 centimeter. They are asking what is the real depth or real distance of this bubble from the first surface, right? So let's call real distance from first surface something x. We want to calculate x, okay? So obviously what is the depth from real depth from the bottom surface? 4.5 minus x. Total side is 4.5. From top I'm real depth I'm calling as x. Then from bottom surface we go what? Bottom, or you say opposite surface, phase 4.5 minus x. Okay. Here refractive index also we don't know. So let's say mu is what? This much. Then we have relations. Let's write for top surface. What relation? You know the mu is called what? H real by H apparent. This is a formula, right? One formula we have this format, or we have this format, or we have what? This format also, that mu is also equal to what? H real by what? H apparent. This formula we write when what we are talking? Object placed in what? Denser medium, and we are watching it from what? Rarer medium. Okay. So let's see. Mu we don't know. H real we don't is what? X here. H apparent given what? 2 centimeter. This is the equation 1. Let's write for bottom surface also same formula. Mu is what? H real by what? H apparent. Mu we don't know. H real is what? 4.5 minus x. Apparent is what? 1. These two equations we have, two things are unknown, mu and what? X. Suppose they ask refractive index, we can find here they are asking the x, the real depth. So just we can replace the value of anything. Let's say mu from this is what? Mu will be what? X by 2. Let's put this value here. So I'm doing calculation here. Look here. Mu means what? X by 2 is equal to 4.5 minus x by 1. So this becomes simply x is equal to what? 9 minus 2x. 3x is what? 9, or x is coming what? 3 centimeter. So this is the real depth from this face, or from this face they are asking, then 4.5 minus x. Suppose they ask now refractive index of this material also, you can find, yes, x you know, so you can find mu also, right? Okay. So this was question number 9. So question number 10 we are talking now. They say the bottom of a container is made up of glass of 4 centimeter thick. Mu is given 1.5. The container contains two immiscible liquids A and B of depth 6 centimeter and 8 centimeter. So this question based on what? Like multiple mediums are there, and we have to find net normal shift due to what? Multiple mediums. So I discuss simply individual shift you have to add. Okay. So they said what is the shift of the scratch made on the outer surface of the bottom glass when it's viewed through the container? The refractive index is given A and B this much. Okay, look here. There is a glass container given to us, and this glass container has thickness, its bottom has somewhat thickness. That thickness is given what? 4 centimeter, right? Yes, and refractive index given 1.5. 1.5, this is a refractive index. Okay, so scratch is made here at the bottom surface, and there are two liquid also filled here. Let's say this is one liquid. So liquid A is given up to depth of what? 8 centimeters filled, and refractive index given as 1.4. There's another liquid here. Let's say this liquid B. This B liquid is filled up to what depth? 6 centimeter, and has the refractive index of what? 1.3. Clear? So they said if a scratch is made at the bottom side, outer surface, right now, outer surface made a scratch, then you watch it from what? Top. Here's your eye. Then this is a real depth. What is real depth? 6 plus 8 plus 4, right now. So it becomes like 18 centimeter. They are asking what is the apparent depth? Yes, they are asking what is shift? Shift, they are asking normal shift. They can ask you apparent depth also. So look here, shift. Normal shift due to multiple medium is what? This NS is what? NS due to what? Your first medium plus second medium. All individual mediums you can add normal shift, right now. So here what is shift due to what? This glass slab. Okay, glass slab has thickness 4 centimeter and mu is given 1.5. So we are writing formula 4 into what? 1 minus 1.5. Normal formula I am writing this formula only. Object is placed in denser medium. Okay, we are watching from what? Rarer medium. Okay. Then normal shift produced due to the liquid A. Real depth is what? 8. 1 minus 1.4 plus normal shift produced due to that liquid 1 minus 1.3. Correct? Yes. Okay. So this number you have to simplify. So you can write answer was given like 4.88 centimeter. This is what your normal shift produced net. Okay. Now what happens, they can ask you what's apparent depth. Suppose really look what at this position, so they can ask you h apparent, then you can write normal shift is what, h real minus what, h apparent also, right? Okay, real depth means this is real depth, 6 plus 8 plus 4 means 18. So this real we know, normal shift we know, so you can find apparent depth, or they can ask you the position of the image simply. This is called position of the object, this is called position of the image. The distance between image and object is also called what, your normal shift, right? Here what can happen, suppose normal shift is given to you, this is given to you, then refractive index of any liquid will be unknown to you. So you can find, right? Normal shift is given, total like 4.88 here, something unknown, suppose this is what written mu, you can find that also, right? Okay, this was question number what, 10. Let's see question number what, 11. 11th question, they are asking that if the critical angle of a certain medium and vacuum is what, 30 degree, right? Find the velocity of the light in the medium. What is given? Critical angle of incident given. So we know the critical angle of incident is what, sine IC is what, 1 by mu, right? Critical angle given, you can find refractive index. Then you have refractive index and velocity relation, right? You know that refractive index is what, velocity in air by velocity in that medium, right? Yes. So first let's calculate here, sine given. So mu will be what, 1 by sine IC. Mu is equal to sine given what, 30. Sine 30 is 1 by 2, so mu becomes what, 2. This is refractive index. Then they are asking velocity in that medium. So velocity in medium is what, speed in air by what, refractive index. Speed in air is what, 3 into 10 power 8 by 2. So it becomes 1.5 into 10 power 8 meter per second, right? That's the speed in the medium. Correct? Okay. Then question number 12 we're talking. So look here, question number 12. They said an object is placed in front of right angled prism ABC in two positions A and B, right? The prism is made by a crown glass with a critical angle is 45 degree. Critical angle of incident given, IC is given as what, 41 degree. Means when light incident this angle, then light will go parallel to boundary of angle of incident is more than this angle. Suppose the light comes at 42 degree, means TIR will happen, total internal reflection will happen. Okay, so critical angle given, and they said two positions are given. Trace the path of the rays starting from P to Q in the figure A and B. Okay, so look here, one prism is placed like that way. This is one position given. Names are given ABC. So that angle is what, obviously 90 degree. This is given 45 degree, and that also given as 45 degree. Clear? Then where's the object placed? Object is placed here in front of this face. This is your PQ object. So they are asking that we have to draw the diagrams. Okay, how rays will look. We have to trace the rays. So look here. Suppose one ray start from P, incident on this surface. How is incident? Perpendicular to surface or parallel to normal only, so angle of incident is 0. When, remember that when light incident like this one, there is no deviation happens, light will go straight and hit this surface like this. Understanding? At this surface, your surface, which surface? AC. On AC surface, rays incident what? Perpendicular to surface or making 0 degree with what? Normal, right? So angle of incident is 0, angle of refraction also 0, light will not deviate at all. Okay, it will pass straight. Now, when it hit this surface, right, then we want to know whether this light will come out or it will get TIR. This we want to know. So let's draw a normal here. This is your normal here. So this is your angle of incident. Let's calculate what is that angle of incident. How? Look at this small triangle first. This angle is what? 90 degree, right? That's 45 degree. This angle should be what? 45 degree. Now this is a normal line, right? So this angle is what? 90 minus 45 is what? 45 degree. It means the angle of incident at that surface, that face, which face? BC face, right now, is what? 45 degree, which is more than the critical, right now. Angle of incident is more than critical angle of incident, means light will get what? TIR. So instead of light going out, light will come like this way. It will hit here, right? Yes. So when light hit here again let's draw normal here. You draw a normal here, right? Yes. So again, what is the angle of incident? Look here. This is 45 degree. That's 45 degree. This is also 45 degree. Again, angle of incident is what? 45 degree. More than what? Critical angle. So again, light what? Get TIR like that way. So when light hit this surface, again it's hitting perpendicular. So it will straight come out. So this point is what? Your which point? P dash point. Right. Same will is trace for Q also. Q light will go like same that way. Hit it here. And will come back. Right. So that will be your q days. Here image will be formed like that way, inverted image. Correct? So if the angle of incident on any surface is what? More than what? What angle? Critical angle, light will get TIR. And also condition that light should go from denser to rarer medium. So here this is denser medium, we try to go in outward rarer medium, right? So it getting what? TIR. Same thing happening what here also. Okay, one more picture is given here. Yes, this your same prism is placed like that way. This is your prism. Name the giving is what? ABC. And in this case they said this angle is 45 degree, that angle is 90 degree. So obviously this will also what? 45 degree, right? And object is placed here. This is your object PQ. Now you have to trace the ray diagrams. Okay, so watch it carefully. Ray start from P, will incident on this surface again perpendicular, so it will not deviate, right? Perpendicular surface, or you say angle of incident 0 degree. Hit on this surface at some angle. What is the angle? Let's draw normal here. This is normal. So look, what is the angle of incident here? 45 degree, 90 degree. This also what? 45 degree. This also become 45 degree, right? Normal. So this is the 45 degree angle of incident, more than the critical angle. So again light will not come out, right? It will get what? TIR. So light will come like that. Okay, this angle also 45 degree. That's also what? 45 degree. Okay, so now look here, in this surface light is hitting perpendicular to surface, so light will come straight out like this way, it will not deviate, right? Now last time like it hitting at 45 degree, so again it what like TIR happening. Here light is now coming straight, so it will pass straight. So this is what your P days point. Now same day you draw your Q also. This is a line that will come like that way, that will be Q days. So PQ, that will be your image. Correct? Hope you understood these questions based on what? Refraction. Please solve all the questions given in exercise 1 based on what? Refraction. Refraction through plane surfaces. Refraction through what? Curved surfaces. Already I discussed with you. Curved surfaces means you have simple formula, just sine convention you have to write carefully. Okay. This is all about what? Refraction. Thank you so much and have a good day. Bye.